Hi everybody. We are working with the same data set this week that we did last week for Google Sheets. So if you have that, if you ended up downloading it on your computer, you can just reuse the same data set. But so here it is again, and the quickest way to copy it, let me get out of this. So they got actual people's actual information from people, a number to help measure tobacco use, and I'll put the article. I don't have it again, but I'll put the source there so you can check it out. LDL levels, obesity level, alcohol, age. I'm not sure how they measure each of these variables, but they probably have some sort of standard that they use. So let's zoom out here. And then I'm going to copy all this data. So I'm holding Shift. Oh, and actually that was not holding Shift. Let's try that again. Hold Shift, click over here. I've got them all copied. And now I'm going to go to Google Sheets. So we'll just type in Google Sheets, pull it up. Just make sure you're signed in so you don't lose your work, just like always. Let's make a new one. If we paste the data, it should be right there. And I can put the CSV file, the comma separated value file, there too. So in case you have trouble copying it, that way you can download it in a nice small format. Okay, so we got our data. Let's start looking at the instructions here. We can make it a little, I don't know why it's 8.5. That's better. So using the same data set from last week, our first task is to figure out which of the following columns linearly correlates most strongly with SBP, systolic blood pressure. So what you're going to want to do is consider that first column, systolic blood pressure, because that was the focus of the researchers when they gathered this data, is looking at systolic blood pressure. And you might want to try systolic blood pressure with tobacco, just putting a name for my correlation coefficient. What we're learning this week is that R is the correlation coefficient, and it's like a number that measures how closely two variables are connected by a straight line. That's the basic layman's terms definitions. Right? You can make a scatter plot for an X variable and a Y variable. Make those dots just like you did in like an algebra course where you go like 5 over in the X, 2 on the Y. Put all those data points on that scatter plot, and then R tells you how closely they make a straight line. If R is 0, that means they come nothing close to a straight line. If R is -1, that means it's a perfect straight line, just it's going down. If R equals 1, that means it's a perfect straight line going up. And so getting exactly -1, +1, that very rarely happens in research. If it does, it usually means we've typed something in wrong. So here's how you do it to check tobacco. We want to see if systolic blood pressure is connected to tobacco use. So we're going to type equals correl, open a parentheses, and then click and drag. The order doesn't matter, the columns. You can put systolic blood pressure first. And now that I've clicked and dragged it, watch, I'm going to put a comma so that I can enter another column. Then I'm going to click and drag tobacco use. And then I'm going to close the parentheses, which is getting off screen for you. There we go. Close the parentheses and hit enter. And there's my correlation coefficient. It's pretty close to 0, right? It's closer to 0 than it is to 1. So it doesn't look like they're too correlated. And so if we want to do the next one, systolic blood pressure and LDL levels. I forget what that stands for. A lot of you guys are in the health sciences, you could tell me. So we need equals correl again, open parentheses, and I think it's A2 to A161. Yeah, 161 is the last one. So I'm going to put a comma, and then my first cell is C2. I'm going to put a colon, and then C161. This is an alternative way of doing it. Last time we dragged all the way down, clicked and dragged, or you could do it this way. You could type the first cell, colon, the last cell, and I find that's a little bit quicker. So it does not look correlated at all with LDL. So keep going. Go through all the variables except family history, because that's kind of like a dummy variable. It's either 0 or 1. okay, and find out which variable it's most linearly correlated to. And so that's your first step. And then you could just, paste all the different correlation coefficients to show you've gone through them. So you should have 1, 2, 3, 4, 5, 6, 7, 8 total. Part 2 says construct the least squares regression equation. So this is, let me type it in here. This is like what we learned in algebra, y equals mx plus b. Or sometimes you see y equals ax plus b. This number in front of x is the slope, and this number over here is the y-intercept. Okay, so to construct that equation, we need the slope, and it wants us to create the linear regression equation between age and systolic blood pressure. Age is the x variable. That means age is the one predicting blood pressure. Blood pressure isn't predicting how old somebody is. I guess you could make an argument, you could do it one way or the other, but so we're all on the same page. We're going to let x be the age column and y be the systolic blood pressure column. And that's important because the way you put in the formula, you'll get a different result if you switch those up. So slope, we type equals slope, and it's automatically the slope of a linear regression line. Open a parentheses, and then I think y actually has to come first, which is pretty counterintuitive. So A2, I think I just said it right there, right? No. A2 colon A161. See how it's highlighted what's going to be my y column, systolic blood pressure. And then x comes second. So age is over here. So I'm going to say I2 to I161. Okay, that's the slope, and I'm going to leave the y-intercept to you so I don't reveal all the correct answers here, okay? Type intercept, open a parentheses, and it's the same thing. The y column has to come first. So systolic blood pressure comes first, comma, age comes second. Let's see. And then part 3 says create a scatter plot. So if we need a scatter plot of these two columns, I'm going to click column A to highlight column A, then hold Control and click I to highlight all of column I. That way I'm telling my scatter plot to work with just these two variables. You can click Insert, Chart like we've done before. Oh, it's already made a scatter plot. But look how it has systolic blood pressure as the x-axis. We said systolic blood pressure was going to be a response variable. It should be the y-axis, so you can switch those by clicking right here. And it's a straight line because I also need to change systolic blood pressure to be my y variable. There's a decent amount of scatter, but it does look like there's a linear trend, right? It looks like it is making a straight line with a slight increase to it, but this is why we want to calculate the correlation coefficient so we can have a more concrete number to say whether it does make a straight line or not. But this is all you have to do for part 3. Create that scatter plot, and you could just like right click it. Oh, let me see. Should be a way to copy it. Right clicking didn't work. Edit, copy, and then you could go into a Word document and paste. No, it doesn't let you do that. So screenshots, I think it's really useful if you get used to the hotkeys on a computer. With Windows, you hold the Windows button, Shift and S, and see how it's pulling up a screenshot tool. I can click and drag, and now I've got a screenshot of just this graph that I can paste into my Word document. If you're on a Mac computer, you just hold Command Shift 4 to do the same thing, and then you can copy a screenshot. There should be a way to copy and paste, but I don't want to waste your time with me sitting around trying to click it. So if you have trouble displaying it too, remember, like, the best way to do this is just leave the graph here, click Share, and then I think it's going to make you name it, and then just send me the link. Just make sure to set the link so that you can right here change link to anybody can have access to it, and then copy and send it to me. And that works great too.